we will move on to our final talk in this session. Willard, Pimentel, and Lee, Lunar South Pole Eclipse landing sites for science and candidate Artemis Base Camp location scouting.
Oh, well, hello everyone. My name is Troy Willard. I'm an undergraduate at the University of Chicago, and I'm going to present potential eclipse landing sites that allow high priority science investigations while additionally scouting candidate Artemis base camps, which I'll abbreviate to ABC, and I'll give an example of such a mission. Next slide, please. As Aaron just presented, we conducted a survey of the lunar South Pole using primarily logistical criteria to assess such as access to solar energy, direct-to-earth capability, access to large flat areas for habitat structures, and separate HLS compliant landing/launchpad areas. And these dots on this map are all of those sites that passed these logistical criteria, with the green dots being those that have more than 75% solar illumination. And what we suggest is considering these candidate sites for eclipse landings to allow ground truth scouting of the surface conditions at these sites, informing future Artemis decisions. Next slide, please. Here are 3 examples of those sites. So we characterize each site as a 2.5 kilometer radius centered on the point of maximum illumination, demarcated by those magenta pixels. This is where a solar panel array would go for a Artemis base camp. And further, the habitat structures could be built in these large black ellipses for each site. And the cyan ellipses mark the HLS compliant landing/launch pad areas, which are separated by elevation to minimize rocket exhaust ejecta. The first 2 sites on the left are extremely high illumination sites near the South Pole. Meanwhile, the third site on the right is at the lower end of our thresholds for solar illumination and DTE, but is an interesting site nonetheless because of its position on the Faustini Rim, which is near Amundsen and Nobile craters. And this is the site I'm going to use to present the framework for an Artemis Base Camp scouting eclipse mission. Next slide, please. And here's an example of that mission. So this would be Eclipse rover traverse on the Faustini Rim, allowing for scouting this candidate ABC site, as well as exploring PSR and geologic science targets. It's approximately an 11-kilometer traverse at less than 20-degree slopes, although a similar traverse is available at less than 10-degree slopes. This white circle at the top of the figure is the 2.5-kilometer radius candidate ABC site that you saw on the last slide. This is where the Eclipse mission would land at the site's potential habitat area. The rover would then traverse and scout to the maximum illumination peak where the ABC solar panels would be, followed by traversing and scouting an HLS compliant landing/launchpad area, which is marked in blue. Then approximately 5 kilometers into the traverse, the rover would enter a small impact crater, which houses a small PSR, allowing for volatiles investigations. And then the final primary target of this traverse would be a high priority science PSR identified by Lemelin et al. In 2021, because of its high mean hydrogen content, which is over 150 parts per million. And there would, of course, be additional stops and targets along the traverse. Next slide, please. So the first 2 science objectives, being volatile and geologic feature exploration, would be answered by neutron, near-IR, and thermal IR spectrometers. While our other objectives of investigating dust transport, exploring candidate Artemis base camp, as well as quasi-permanently lit areas can be accomplished with just rover imaging. We would need the rover, of course, to be able to traverse approximately 10 kilometers of distance, as well as 10 to 20 degree slopes, as well as being able to enter these PSRs for direct observations. And of course, the enhancing capabilities of such a mission would be increased roving distance, as well as increased thermal resilience, which will allow deeper PSR exploration. Next slide, please.
1 minute.
Thank you. And I just want to conclude by pointing out that this is a mission framework that can be modified for most of our candidate ABC sites. The Shackleton to Gerlosh Ridge, Mount Kosher, and Mons Malapert sites are all eclipse sites that have been mentioned either in talks or by posters in this workshop, and they're also potential candidate targets for an Artemis base camp, and therefore can be used in CLPS to explore their potential use. The Artemis Base Camp will be a significant investment by NASA and the scientific community, and therefore missions like this could be ideal for informing that future decision. That's all I have. Thank you.
All right, thank you very much.